Hello friends, in the last lecture we have discussed about the coefficient of restitution for the elastic collision, the inelastic collision and the perfectly inelastic collision. In this lecture now we are going to discuss about the expression for the final velocities after a head-on collision, head-on elastic collision in terms of the masses of the bodies and the initial velocities of the bodies. Now, according to the definition of the elastic collision, so according to definition of elastic collision, number one, the linear momentum is conserved. So, linear momentum is conserved. That is, initial momentum is equal to final momentum. Therefore, m1, when the two bodies are colliding having masses m1 and m2 and initial velocities u1 and u2 and final velocities v1 and v2. So, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So, we rearrange here m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. So, m1 u1 minus v1 is equal to m2 v2 minus u2. So, this is the equation 1. Next, that is the kinetic energy is conserved. That is the kinetic energy initial is equal to kinetic energy final. That is half m1 u1 square plus half m2 u2 square. This is equal to half m1 v1 square plus half m2 v2 square. Now, we rearrange the terms of m1 on this side and m2 on this side. So, half m1 u1 square minus half m1 v1 square. This is equal to half m1 half m2 v2 square minus half m2 u2 square. So, half taking common, m1 u1 square minus m1 v1 square. This is equal to half m2 v2 square minus m2 u2 square. So, multiplying both the sides of the equation by 2 and the half and the 2 get cancelled. So, we get m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Now, taking m1 common, so m1 u1 square minus v1 square, that is equal to m2 v2 square minus u2 square. So, we get here m1, this is a square minus b square. It is, we have to expand it like a square minus b square, that is a plus b into a minus b. So, m1 u1 plus v1 into u1 minus v1. This is equal to m2 v2 minus u2 upon v2 plus u2. So, this is equation 2. So, dividing equation 2 by 1, dividing equation 2 by 1, we get, I rearrange it, m1 u1 minus v1. मी त्याला फक्त लिहिताना हे इक्वेशन रिअरेंज करते आहे. सो आपल्याला m1 u1 minus v1 into u1 plus v1. This is equal to m2 v2 minus u2 into v2 plus u2. This is divided by m1 u1 minus v1 and here m2 v2 minus u2. Now this m1 cancel, u1 minus v1 and u1 minus v1 cancel, and this m2 cancel, and v2 minus u2 and v2 minus u2 cancel. We get u1 plus v1 is equal to v2 plus u2. So this is one expression. I rearrange it and I take u2 here. So we get v2 is equal to u1 plus v1 minus u2. So let this be equation 3 and let this be equation 4. So now again we come to the law of conservation of linear momentum because the collision is elastic. So according to law of conservation of linear momentum, we have from this law initial momentum is equal to the final momentum. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So we know we had written this equation as equation 1. So from this equation 1 and 4 we get from and 4. For this v2 here in the equation 1 we write the value of v2 in equation 4. So we get m1 u1 plus m2 u2. This is equal to m1 v1 plus m2 and v2 is u1 plus v1 minus u2. So u1 plus v1 minus u2. So we solve the equation m1 u1 plus m2 u2. This is equal to m1 v1 plus m2 u1 plus m2 v1 minus m2 u2. Now we rearrange the terms of v1 in this side and the u1 and u2 on this side. So we rearrange the terms. We get m1 v1 चे टर्म्स एका बाजूला लिहिते आणि m1 u1 आणि m2 u2 चे टर्म्स एका बाजूला लिहिते. So we get m1 u1 plus m2 u2. Now this is m1 v1 term. This is m2 u1 term. So this is plus. So I take it here. So it becomes minus. So minus m2 u1. And this is minus m2 u2 term. So when I take it here, it will become plus. So plus m2 u2. This is equal. So these two terms I have shifted on the left hand side. So the terms remaining on the right hand side are m1 v1 plus m2 v1. Now this right hand side I write here on the left hand side. So I get m1 v1 plus m2 v1. This is equal to m1 u1. For this I again rearrange and I take the terms of u1 near each other. So minus m2 u1 मी u1 u1 ची टर्म जवळ घेतली plus m2 u2 plus m2 u2. Now here v1 is common. So इथे v1 मी ब्रॅकेटच्या बाहेर घेते m1 plus m2. So this is. Now this is m1 u1 minus m2 u2, m2 u1. So u1 मी ब्रॅकेटच्या बाहेर घेते, so I get m1 minus m2, and this is m2 u2 and m2 u2, so this is plus 2 m2 u2. So now dividing the left hand side and the right hand side by m1 and m2, so we get v1 m1 plus m2 upon m1 plus m2. This is equal to 1 upon m1 plus m2 into u1 m1 minus m2 plus 2 m2 u2. Again, so we can cancel, these two terms are same, so we can cancel them. So again we rearrange and write v1, this is equal to u1 m1 minus m2 upon m1 plus m2 plus twice m2 u2 upon m1 plus m2. So we rearrange, v1 is equal to m1 minus m2 upon m1 plus m2 into u1 plus twice m2 u2 upon m1 plus m2. So this is the expression for the velocity of the first body having mass m1. Now similarly, याच पद्धतीने ट्रीटमेंट देऊन आपण we can find the velocity for the body of mass m2. So similarly, v2 is equal to m2 minus m1 upon m1 plus m2 into u2 plus twice m1 upon m1 plus m2 into u1. So this is the formula for the final velocity of the body of mass m2. By the same procedure, we find it. So in this way, we have found the expression for the final velocities of two bodies which are colliding, but the collision is elastic collision and the collision is one-dimensional collision or head-on collision. So now, up till now we have found out the velocities, the final velocities of the two bodies after the elastic collision. So we have found out the v1 and we have found out the expression. We have found out the expression for v1 and we have written the expression for v2. Now, we will discuss some particular cases. So, case 1 is when if both the bodies are not of different masses but they are of same mass. So, m1 is equal to m2. So, when m1 is equal to m2, so now this will be case 1. We are going to discuss m1 is equal to m2 is equal to m is the bodies, both the bodies have the same mass. So, we will find out the final velocities. So, v1 is equal to, so m1 minus m2, that is will be equal to 0. So, 0 upon m1 plus m2 is equal to m. So, this will be 2m into u1 plus this is 2m2 is m. So, 2m upon m1 plus m2 is 2m because both masses are same into u2. Now here this is 0. So, this term will get cancelled. This 2m will cancel with this 2m. So, we get v1 is equal to u2. That is the final velocity of mass m1 will be the initial velocity of the second body of the same mass. And now for v2, the final velocity of the second body, having the mass same. So m2 minus m1. So this will be m minus m, that equal to 0 upon 2m into u2 plus, this is again 2m, m1 plus m2 is 2m into u1. So v2 is equal to, now this will get cancelled because the numerator is 0. This here 2m will get cancelled. So we get v2 is equal to u1. So the final velocity of the body of the second body will be equal to the initial velocity of the first body, and the final velocity of the first body will be equal to the initial velocity of the second body. That is, only the velocities of the two masses, they are of the same, their masses are same, but their velocities interchange. Now the next case is when one body is very much bigger and another body which is striking, this is m1 and this is m2. So m1 is very much greater than m2 and m1 is moving with velocity u1 and u2, that is the velocity of m2, is 0. That is, this big, very big body is striking or is colliding with a very small body of very small mass. So what we can say, that here we can say m1 plus m2 is nearly equal to m1, because the mass of m2 is very small. This is very small body. So the addition of both the masses will be the addition of the mass of the body. This was because this is very small. Also we can write m2 upon m1 plus m2. m2 is a body having point mass, very small, and m1 is a very big. So numerator is very small and denominator is very big. So this will also be nearly equal to 0. So now we write the velocity v1 is equal to m1 minus m2. This is equal to m1 because m2 is very small, upon m1 plus m2. This is also equal to m1 into u1 plus twice m2 upon m1 plus m2 is m1 into u2. So here m1 gets cancelled. This m2 is very less than m1. So denominator is very large and numerator is very small. So this will become nearly 0. So we can write v1 is equal to u1. That is, the velocity of the very big mass v1 is its initial velocity. Initially its velocity was u1, and now after collision with the very small object of mass m2, its velocity has not changed at all and it is remaining the same, that is u1. So v1 is equal to u1. Also about v2, what will be the velocity of this small object? So v2 is equal to m2 minus m1. So m2 minus m1 is minus m1 upon m1 plus m2 is m1, because m1 plus m2 is m1 and m2 minus m1 is minus m1. This into u2 plus twice m1. m1 is very big, so m1 upon m1 plus m2 is m1 into u1. So this cancel, v2 is equal to, we get minus u2 plus 2u1. But u2, which is the initial velocity of the small object, is 0. So this will become 0. So we get v2 is equal to twice u1. So the final velocity of the small object is now twice the velocity of the bigger object. The velocity of the bigger object remains the same. The final velocity remains the same, and the final velocity of the smaller object is twice the initial velocity of the bigger object. Now, in the case 3, we are going to discuss that m1 is very much less than m2. m2 is a very big body. m1 is a very small body, and the initial velocity of m2 is 0. That is, this is m1, very small body of mass m1, and m2 is a very big body of mass m2. So this body is now striking this body. m1 is striking m2. So, and the initial velocity, m1 has initial velocity u1, and initial velocity of body m2 is u2 is 0. So now we will discuss what will be their final velocities after collision. So v1 is equal to m1 minus m2. So m1 minus m2 upon m1 plus m2. So m1 minus m2, m1 is very small, so we get here minus m2, upon m1 plus m2 is m2. So this is m2. So here we write minus m2 upon m2 into u1, and here we get twice m2 upon m1 plus m2. So m1 plus m2 is again m2, because mass of m1 is nearly negligible or 0 as compared to the mass of m1 is 0 as compared to the mass m2. So this is here u2. So v1, m2 cancel, we get minus u1 plus twice, but here u2, the velocity, initial velocity of u2, m2, that is u2 is 0. So this is 0. So we get v1 is equal to minus u1. So this object, when this m1 object, when it collides on this m1 object, when it collides on m2, it rebounds back with the same velocity, its same initial velocity, u1. So it is like when I throw a ball on the ground is on the earth is a body of very large mass as compared to the mass of the ball which I have in my hand. So when I throw the ball on the ground, it rebounds back. If the collision is elastic, of course, it will rebound back with the same velocity. So this is, and for v2, m2 minus m1. So m2 is very large, m1 is small. So I get here m2 because m1 is very small. And also m1 plus m2 is m2 into u2 plus twice now this m1 is very small. So this is nearly equal to 0 upon m2 into u1. So now we know that u2 is equal to 0. So we get here v2 is equal to 0 plus this term will also be equal to 0. So we get the final velocity of the mass m2, that is v2, will be equal to 0. So v2 will be remaining untouched. There will be no change in the velocity. Only the velocity of the object m1, which is very small and which is coming and hitting the very big mass, the velocity of this object is reversed. So these are the 3 particular cases for which the final velocities of the two bodies we have discussed and found out. Thank you.